Good afternoon, ladies and gentlemen. Today we're going to be learning a little bit about exponents and how they compare to numbers that we're more familiar with, which are multiples. What I'd like you to do is take a look at the top of your flip chart here, and you'll notice 4 to the first power. That means that the base is 4. The word is base is 4. The exponent, ooh, my pen is acting up. Exponent is 1. That's how we get 4 to the first power. That means that there's 1 4, and therefore 4 to the first is 4. Now some of you might be saying, wait, that's a lot like 4 times 1, but you'll see in a moment why that's different. Look now at the next exponent, which is 4 to the second power. The base is 4, the exponent is 2. That means it's 4 multiplied by itself twice. 4 times 4, which is 16. And there's a visual representation there for you so that it makes more sense. Look at the next one then. That is 4 to the third power. The base is 4. The exponent is 3. 4 times 4 times 4, which is 64. And once again, there's a visual representation there. Take a look at the last one that we have here, and that's 4 to the fourth power, or 4 times itself 4 times. 4 times 4 times 4 times 4, and that equals 256. Now some of you might be saying, wait a second, how is it 256? Because 4 times 4 is 16. Well, look at the bottom, and you'll see the difference between exponents and multiples. Here are the multiples. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16, and 4 times 5 is 20. Exponents are different because they don't do what multiples do. Multiples just multiply the number by another number in order to get what the multiple of that number is. But for exponents, we do we do whatever the base is, and the exponent tells us how many times to multiply the base by itself. So for example, 4 times 4 is 16. We multiply 16 then by another 4, and we get 64. We multiply that by another 4, and we get 256. All right. Moving right along, go ahead and take a look at this web page, or this flip chart. And you'll notice that there's a pattern that develops. We see 3 to the fifth power. We multiply 3 by itself 5 times to get 243. Now I added, I tagged onto the side here the multiplied by 1, and you'll see why in just a moment. Here's 3 to the fourth, and once again we have 1 times 3 times 3 times 3 times 3, which is 81. Once again, that 1 is there, and as you know, the identity property of multiplication tells us that 1 times any number does not change the value of that number. That's why I can put that 1 there. So 3 to the third power is 3 times 3 times 3. Once again, I tagged on that 1 times 3 times 3 times 3, and you'll see why. That's 27. 3 to the second essentially is 3 times 3, which is 9. 3 to the first, it means only 1 3 is left there, and that is 3. And now you'll see why I put that 1 there. Because any number to the 0 power is 1. Why? Because there are no 3's there. You'll notice there are no 3's next to that 1. Therefore, it's only 1. 4 to the 0 power is 1. 5 to the 0 power is 1. 1,000 to the 0 power is 1. They all equal 1. Here's a little bit of a challenge for you. 3 to the negative first is 1/3. The reason being it's 1 over only 1/3. That's how we get 1/3. 3 to the negative second is 1 over 3 times 3. That's why we get 1/9. Notice that 1/3 is the reciprocal of 3, because 3 as a whole number can be written as a mixed number, 3 over 1. Notice that 1/9 is the reciprocal of 9, because 9 can be written as 9 over 1. The word I've been using is reciprocal. Reciprocal. All right. Now, what I'd like you to do is try this on your own, please. Please pause the video in just a moment, and that way you can go ahead and try this on your own, and then go ahead and push play, and you can check to see how you did. Okay, go ahead and pause it. Okay, let's see how you did. Here, we were given the expanded form, and now we need to figure out what the exponent and product look like. So, we notice that there's 1, 2, 3, 4, 5 2s. So that's 2 to the 5th power. When we're solving that, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now it gets a little bit more challenging because all they give us is 9. So we have to think of one number that when we multiply it by itself a certain amount of times can come up with 9. Well, we know that 3 times itself is 9. So 3 to the 2nd power is 9. Now we have exponent form of 5 to the 3rd power. In expanded form, that would mean we need 3 5s multiplied by each other. So 5 times 5 is 25, times another 5 is 125. And now at the very bottom, you'll see 10 times 10 times 10 times 10. Well, that is a base of 10 to the 4th power. And therefore, that will be 10,000. Why 10,000? Because 10 times 10 is 100. Multiply that by another 10, and we get 1,000. Multiply that by our last 10, and we get 10,000. I'd like to just challenge you here for a moment, and what I'd like you to do is try to do 10 to the negative 4th and see what you think you can come up with. Well, we know that 10 to the negative 4th is going to be the reciprocal of 10 to the 4th. So, it's going to be 1 over 10 times, I'm using dots now for multiplication, times 10 times 10. So we have 10 times 10 times 10 times 10. And that will equal 1/10,000th. I apologize for my pen. It's a little messy. All right, I hope that helped you with your exponents. Please feel free to come back to this at any point and to review exponents. Thank you.